lovers. We're on notes number 17 today, lesson 1.1. We're going to talk about graphing. Now think about why we graph. What's the reason we graph? Is it just because we like to draw pictures? Well, actually, we graph because we have so many different solutions. We want to show our reader all the different possibilities that we have for our solutions. So suppose I pick number 17 from your textbook. I have y is equal to x squared minus 3x. I could spend all day just going through all the possible solutions that I could have for this. We have so many other math problems to do. Maybe back in the day, you would start by making a t-chart. We all love our t-charts. Maybe you put in -2, -1, 0, 1, 2, and to see what's going on. Maybe we'll even put in 3. And so you put your values in. You're going to put a 2 in for the x. So -2 squared is 4 minus 3 times -2. That's going to be plus 6. That would be, of course, 10. -1 squared is 1. Well, -1 times -3, that's plus 3. That's going to give me 4. Put in a 0. We love 0. 0 minus 0 gives me 0. 1 squared minus 3 is -2. And then 2 squared would be 4 minus 6 equals -2. 3 squared would be 9 minus 9, which would be 0. Okay, so if I go ahead and I graph those points on my Cartesian coordinate, leaving this one x, this one of course is y, I would have, oh goodness, I would have 2, 10. Well, that's going to be, good job, Glennon. That's going to be like way -2. That's going to be like way up here, right? -1, 4. That's going to be like here. I'll have 0, 0. I'll have 1 over 1, -2, which would be here. I have 2, -2. That would be here, right? And then 3 would be back here at, actually this would be like here. So anyway, I'm going to have this graph where it's going to cross through and go up like this. It's a parabola. You knew it was going to be a parabola because we looked right away at the x squared term. You know, you're not going to do this for every single problem we're going to look at. It's going to take you forever to make it's going to make you forever to make a t-chart. This, of course, is our line of symmetry. It cuts it in half, all right? We know our line of symmetry. It's halfway between the zeros. I could find my vertex. My zeros are where the graph is going to cross the x-axis. That's where the y value is 0. So those points here, my zeros are 0 and 3. Now I know you're thinking, you say the 0 is 3. Yes, the 0 is 3. The 0 has a value of 3. That's where it's going to cross right here at 3, okay? You could double check this by pulling out your calculator. You can use the trace function on your calculator. You can go to second, calculate, and then choose zeros to find the zeros here. Or you can, of course, have a table of values here. So, but my 0 is going to be halfway in between 0 and 3. The vertex there is going to be 1.5. All right, now some graphs that you should know. These are your core graphs, all right? These are graphs that you should know off the top of your head. Like you looked at this one, excuse me, and you knew that it was going to be a parabola, right? All right, so if I say to you y is equal to x, you know that that graph is going to be the identity. Every x is going to look like every y value, and that's going to be the identity. If I have y is equal to x squared, straight up, you know that's going to be a parabola. Vertex right here at 0, 0. If I have y is equal to the absolute value of x, okay, absolute value, that's going to look a lot like this one, but all of my negative values are going to pop up and they're going to be positive. So here I have a nice little V graph, all right? Then, of course, we have y is equal to x cubed, little line here. Y is equal to x cubed. That's going to be a beautiful curve like that because what it's going to do is it's going to take all of these values here and cube them. So if it was a negative value and it was squared, now it's going to flip down to the bottom because it's now cubed. And then, of course, I have y is equal to the square root of x. Not sure if you've done a lot of those. That's going to start here at 0, 0, and it's going to curve off like that. That's a fun one. So you should start to get real familiar with your core graphs. If you're not sure of them, there's some nice inside cover of your textbook They have all the core graphs that you can look at, so you can study them. You're late at night when you're just trying to get to sleep and you stare at your core graphs. It'll help you. I want to talk about the test for symmetry. Okay, test for symmetry with an M. All right, that's in your textbook on page 80. You can look in your textbook for that. But the test for symmetry. So what you're going to do is you're going to figure out what's going to happen. All right, you're going to try to find your symmetry. So what we're going to do is we're going to talk about how our graph looks. Now, suppose I have, I'm going to do this a little different. I want you to finish the graph. Finish the graph with an E. All right, finish the graph. So here's the graph I'm going to give you, and it's going to look like this. We've got different kinds of symmetry. If I have a graph that looks like this, so I'm going to give you with 3 different beginnings, and I want you to graph the rest of it with different symmetry. So this first one, I want you to make symmetric about the x-axis. This one's going to be symmetric about the y-axis. This one's going to be symmetric about the origin. Okay, symmetric about the origin. All right, so grab a nice little pencil here. Love the pencil. So if I want it to be symmetric about the x, that means this axis is going to cut it in half, all right? So this axis is going to cut it. So that means my other half is going to be down here. So yeah, it's symmetric around the x-axis. Symmetric around the y. Well, here's my y-axis. This is where it's going to cut it in half. So I'm going to have a second half of the graph right there. This third one, symmetric about the origin. So here's my origin. That's going to be symmetric over the y and over the x. So that's going to flip it and then turn it right down. So those are the 3 different kinds of symmetry we're looking at. The big ones of over the x, over the y, and over the origin. Now later on you're going to learn about symmetric over the y. That's going to be what's called an even function. And symmetric over the origin later on is going to be called an odd function. Those are the 2 big ones. So put that one in your back pocket because it's coming up later on. So test for symmetry. All right, what you're going to do is you're going to replace, all right, you're going to replace x with the opposite of x, okay? And you're going to look at the changes that it's going to happen. What happens to y? So changes to y. Okay, that's what you're going to think about. Hey, what's going to happen? Let me give you an example. Let's look at number 28 from your textbook. That is y is equal to x to the 4th minus x squared plus 3. Okay? So we're going to take this function and we're going to replace it with the opposite of x. Let's see what happens. So if I'm thinking about over here, like, what happens to it? So y is equal to the opposite of x to the 4th power minus x opposite, oops, I got like 2 minuses signs in there, plus 3. Is there going to be any change? No. You got a power of 4, you got a power of 2, right? So this is going to be exactly the same thing. If it stays exactly the same, all right? So notice the graph over here. It's going to stay exactly the same, all right? So this is going to have symmetric about the y. This is going to be symmetric about the y-axis, or we're going to call that even. In later chapters, we're going to call that even, all right? I can do the same thing to see if it's symmetric about the x. So what I can do is I can try to figure out the opposite of y. Do you notice how it's going to go down as well too? So let's see. All right, I can take the y. I can let y equal the opposite of y. This is going to be just so weird because I already know the answer, you know. All right, is that the same? Is it the same? Is that the same? Absolutely not. No. So it's not symmetric about the x-axis. Okay, we already knew that answer because it was even. And the last one, symmetric about the origin, what you're going to do is you're going to say, you're going to let the x equal the opposite of x and y equal the opposite of y. Now, we know this is not going to work. I feel like I'm wasting my time, but for the sake of argument, I'm going to go ahead and do it anyway for you. All right, so is this the same? Does the opposite of x equal x to the 4th minus, did my problem change? Yeah, no, it's not the same, all right? So what I like to do with symmetry, and to be completely honest with you, because you're emerging learners, all right, your Ron and the textbook, they have this nice test for symmetry on page 80. All right, what I prefer to do is to have you pull out your TI-84. I want you to look at this graph. I want you to think about what kind of graph is it going to be. I know it's got an even power, so it's going to more look like a parabola than anything else. And I want you to think about your symmetry. You can do this all algebraically if you feel like it, but I really prefer the whole graphing method because that makes the connection between the equation and the graph, all right? So have fun with your problem set. Enjoy.